This is going to be our third lecture of Module 1. In this lecture, we're going to be going over working in dedicated space as provided in Article 110. So our objectives for this lecture, we're going to identify requirements of the NEC for working space around equipment and conductors. That's an important note there, as we have different working space for the equipment itself as well as the conductors themselves. We're going to identify requirements of the NEC for dedicated space around equipment. Another note there is a difference between working space and dedicated space. Those are two separate terms. We're going to successfully use and reference Table 110.28, and we're going to understand different requirements for indoor and outdoor equipment. So we have different working and dedicated space requirements for equipment depending on if it's located inside or outside. Our definitions, nominal, once again, same as our last lecture. Throughout the course, we'll begin getting repeats of some definitions, and I'll less and less be going over those and more just letting you read those at your own leisure. We will be talking about an enclosure. Enclosure you can essentially think as an equipment housing or a box of some type. And dedicated means it's for a specific, or as they phrase it in the definition, a particular purpose. So it is specifically for one thing and one thing only. So starting off here, Article 110, we're going to be looking at Part 2, 1,000 volts nominal or less. And this is going to be starting on page 47 of your 2017 NEC. Working spaces for equipment must comply with 110.26A1 through A4, and we'll be taking a look at A1, 2, and 3. A4 isn't really that noteworthy or important. It's really going to be A1, 2, and 3, which cover depth, height, and width. So as I just kind of prematurely mentioned, we have three dimensions required for working space, which are going to be depth, width, and the height of the space. You have to think we're talking a three-dimensional space, so we have all three of those we have to consider. And requirements for over 1,000 volts are covered in Part 3. As I mentioned in our last lecture, I typically don't go over the 1,000 volts requirements because once you learn the 1,000 volts over requirements, because once you learn the 1,000 volts and less, it's just going to be different numbers essentially for the 1,000 volts and over. So starting off, we're going to be looking at A1, which is going to be the depth of the working space. And a quick note, working space, what we're actually talking about here is if we think about just a typical panel, for example, we want to have some space in front of that so that if someone needs to access that panel or perform work in that panel or anything with it, we want that given area to be just free of other stuff, whether it be other equipment or someone using the front of that for storage of parts or materials. We want so much space for people to get inside of and do work and to access the panel and other things. And that's true for any type of equipment that we talk about, whether it be a disconnect or a switchgear or a transformer. So the depth of the working space must comply with Table 110.26A1 unless requirements of 110.26A1A, B, or C are met. So in normal circumstances, we're going to be looking at 110.26A1. However, we do have some exceptions for A, B, and C of 110.26A1. So A1A tells us the working space is not required at the back or sides where all connections and renewable or adjustable parts are accessible from locations other than the back and sides, or sides rather. So in other words, at the back of the equipment and the sides of the equipment, we do not have to have a dedicated working space if we can access all those things they list somewhere other than the back or the side. And however, where rear access is required for non-electrical parts, so rear access to the equipment, we have to provide a working space of 30 inches. A1B tells us by special permission, when all parts operate at 30 volts or 60 volts DC. Special permission, typically this is going to mean the AHJ, as we talked about in our first lecture of the course, giving special permission or waiving certain requirements. And A1C tells us in existing buildings where access to the equipment is limited to qualified personnel with written procedures. So this is typically achieved a lot of times by having a dedicated electrical room for the equipment. You know, you have locking doors to the electrical equipment that only certain people have keys to or card access to. So this is going to be the table. We're going to have tables for most of these that cover the working space requirements. This is going to be called Table 110.26A1. As you may notice, that table name is the same section name as the depth requirement, 110.26A1. And this is the common layout for tables in the NEC, is that the table will have the same naming as the section that relates to it. So section 110.26A1 talked about depth of working space, and table 110.26A1 shows the different depths of working spaces. So this is the first table in the course that we're really going to go in depth talking about how to actually use. I know we looked at 110.20 or 310.15B16 in the previous lecture, but we didn't really go into a whole lot of detail with it. But we will be doing this. So the way we use this table is, first thing is the same as every other table in the NEC. We're going to read this table from top to bottom, left to right. We always read tables in that order, top to bottom, left to right. So starting at the top and on the left, we have a nominal voltage to ground. So this would be a single phase voltage, meaning if we take a voltmeter or a multimeter and we read from one current carrying conductor to ground, we have three different categories that we can fall in, which are 0 to 150 volts, 151 volts to 600 volts, and 601 volts to 1,000 volts. And remember, if it's over 1,000 volts, that's going to be covered in Part 3 of Article 110. It's not going to be included here. Now moving to the top right, we have minimum clear distance, and we have condition 1, condition 2, and condition 3 underneath of that. So depending on what voltage we're at, and then which of the three conditions we fall into, we're going to have a different depth of that working space. So let's take a look at those three conditions below the table. Condition 1 says exposed live parts on one side of the working space and no live or grounded parts on the other side of the working space. Or exposed live parts on both sides of the working space that are effectively guarded by insulating materials. Condition 2 tells us exposed live parts on one side of the working space and grounded parts on the other side of the working space. Concrete, brick, or tile walls shall be considered as grounded. And then condition 3 is exposed live parts on both sides of the working space. So just reading those, you may have noticed that each one sounds a little bit more dire of a type of situation than the previous one. So, and to kind of illustrate that point, if we look at the 151 volts to 600 volts rating, and we look at condition 1, 2, and 3, we see that we need a little bit more working space for each of those conditions. So 151 volts to 600 volts, condition 1, we need a depth of 3 feet. Condition 2, we need a depth of 3 feet 6 inches. And condition 3, we need a depth of 4 feet. And like I said, that kind of illustrates the point of each one of those as being a little bit more dangerous of a type of situation. You know, it's more dangerous if we have live parts on both sides of the working space, condition 3, than if we have exposed live parts on one side, and on the other side we have parts that are guarded and protected from contact. So a quick example of how we would actually use this table in application. let's say we had a circuit that was rated at 480 volts to ground, and we had a piece of equipment that circuit supplied, and that piece of equipment had exposed live parts on one side, and then it had grounded parts on the other side. Knowing that it has, we'll start off with, since it's 480 volts to ground, that would put us in our middle row being 151 to 600 volts. Knowing that we have live parts on one side and grounded parts on the other, we read through our conditions, we would find that that meets the requirements of condition 2. So now we would go to condition 2 in our columns, go down to the middle row, which was our 151 to 600 volts, and we would see we need a depth of 3 feet 6 inches for that working space. Moving on from the depth of the working space, now we're going to be taking a look at the width and the height of the working space. Both of these are much simpler to figure out than the depth of the working space. Looking at A2, which is going to be the width of the working space, the width in front of equipment must be the width of the equipment, or 30 inches, whichever is greater. And that's all there is to the width. So essentially, if we have a piece of equipment that is 48 inches wide, since 48 inches is more than 30 inches, the width of the working space would be 48 inches. If we have a piece of equipment that is 20 inches wide, then we would need a working space of 30 inches, since that is the minimum width of working space we are allowed to give to any type of equipment. It must and also the width of the working space must permit at least a 90-degree opening of all doors and hinge panels, and this is obviously to facilitate accessing the interior of that equipment. The height of the working space must extend to a height of 6.5 feet, or the height of the equipment, whichever is greater, and we do have a couple of exceptions to that, which are in existing dwelling units for equipment that does not exceed 200 amperes, and for battery systems mounted on open racks. So, in other than these very specific, very particular situations, our working space is going to be either the height of the equipment or 6.5 feet. Whichever one is greater. So if we have a piece of equipment that's 8 feet tall, we need a height of working space that is 8 feet tall. If we have a piece of equipment that is 4 feet tall, we need a working height that is 6.5 feet tall, since that is going to be the minimum we ever have for a height of working space. So moving on from the actual dimensions of the working space now, we're going to be talking about entrances and egresses. So this is going to get us in and out of access to the equipment. We're going to be looking at the general requirements for that. So we have to have at least one entrance to give access to and egress from working space about equipment, which makes sense. We need some way to actually get into the working space. Now, for equipment rated 2,000 amps or more that is over 6 feet wide and contains overcurrent devices, switching devices, or control devices, so an example of this would be a large 2,000 amp or higher rated piece of switchgear, there must be one entrance at least 24 inches wide and 6.5 feet high at each end of the working space, unless 110.26 C2A or C2B are met. So in other words, if we have a really big piece of equipment, has some certain types of parts in it, we need one at an access to and egress from at each end of the equipment, which makes sense. And illumination must be provided for working spaces around service equipment, switchboard, switchgear, panel boards, or motor control centers installed indoors. Which also makes sense because obviously we want to be able to see the equipment indoors. So we've talked about working space a lot. We've talked about the egress and whatnot for that working space. Now we're going to be taking a look at dedicated equipment. As I mentioned at the start of this lecture, there is a very specific difference between working space and dedicated space for equipment. So we're going to be talking about that now. So all switchboards, switchgears, panel boards, and motor control centers must be in dedicated spaces and protected from physical damage. So in other words, we can't just set a switchboard or a switchgear, the things that list here in 110.26e, we can't just set those in any given old space where it fits. We have to have a dedicated area just for this type of equipment. And it also has to be protected from physical harm by some means. Requirements for indoor equipment are covered in 110.26E1. So once again, we have different requirements for indoor, outdoor equipment. Indoor equipment is going to be covered, as we say here, in 110.26E1. And outdoor equipment is going to be covered in 110.26E2. Taking a look, first of all, at indoor equipment, once again, 110.26E1. Indoor equipment spaces must comply with 110.26E1A through E1D. So that's going to be 4 separate requirements for the dedicated space for indoor equipment. E1A tells us, and this is once again talking about the dedicated space now. So this is where the equipment is actually going to sit at, where it's going to be physically located at. Must be equal to the width and depth of the equipment and 6 feet above the equipment or the structural ceiling, whichever is lower. In other words, we need to have enough space there to actually physically set the equipment. And nothing other than electrical equipment is allowed in this area, with an exception of if we have a suspended ceiling with removable panels. Those are allowed, obviously, because we can remove those panels in order to access that dedicated space. E1B tells us that non-electrical systems are allowed, in contradiction to E1A. They are allowed, as required by E1A, if protection is installed to avoid damage to the electrical system. So in other words, if we imagine a situation where we have a piece of electrical equipment sitting, whether it be a switchboard, switchgear, panel board, or an MCC, since those are the only things we care about with the dedicated space, and there needs to be a sprinkler line run right below, say at 5'10" above that equipment, which is in our 6 feet equipment space above the equipment. As long as we protect the equipment from damage from possible water in that situation, then that would be permitted. With sprinklers specifically being permitted in the dedicated space as permitted by E1C. And kind of what we had talked about with E1A with the drop-in ceilings with removable panels. E1D specifies that dropped and suspended ceilings are not considered structural ceilings. So like I said, this is kind of a repeat of that little note on E1A. Now we're going to talk about the same concept, dedicated equipment space for outdoor equipment. So outdoor equipment must comply with 110.26E2A through C. So we only have 3 requirements for outdoor equipment as opposed to 4 for indoor equipment. So E2A tells us that the dedicated space for outdoor equipment must meet all the following. Must be installed in identified enclosures, must be protected from unauthorized personnel or vehicle traffic, and it must be protected from leakage or spillage from piping systems. So E2A is kind of a large culmination of a couple of the other points for 110.26 for indoor equipment that we talked about. In other words, the equipment's going to have to be installed in something that protects it from the outdoor environment and whatnot, and we also don't want unauthorized personnel or vehicle traffic access to it, especially vehicular traffic. We don't want someone ramming into this with their vehicle, obviously. E2B tells us that it has to meet the working space requirements of 110.26A, and E2C tells us the dedicated equipment space in 110.26E1A. So in terms of the actual dimensions of the space, the only requirements that E2A through C gives us is to refer back to E1A, which once again told us the width, depth of the equipment, and then a height of 6 feet above the equipment for outdoor equipment as well. So in talking about working space law, we obviously, with our conditions 1 through 3 for our depth of working space, we talked a lot about live parts of equipment. We're going to be taking a look at some of Article 110's requirements for how we have to guard live parts of equipment now. So unless otherwise required or permitted, live parts of equipment 50 volts to 1,000 volts must be guarded by one of the following. Must be located somewhere only accessible to qualified persons, permanent partitions or screens arranged so only qualified persons have access, located on an elevated platform, elevated above the floor or working space as follows: 8 feet for 50 to 300 volts, 8 feet 6 inches for 301 to 600 volts, 8 foot 7 inches for equipment 601 to 1,000 volts. I'm sorry, clicked once too many there. So all this, it's a lot of different bullet points to essentially say, using one of the means here, if we have equipment with exposed live parts, we have to protect people from coming in contact with it by one of the means here. You know, we don't want people to just be able to walk up to exposed live parts of equipment and touch them and thus be shocked or electrocuted some way, is the whole purpose of this 110.27a. So in talking about the outdoor equipment, we very briefly mentioned has to be installed in a suitable enclosure, but we do have some specific requirements for different enclosure types here, which we're going to be taking a look at with 110.28. So enclosures must be marked with an enclosure type number shown in Table 110.28. Table 110.28 must be used for selecting enclosures in all but hazardous locations. And enclosures are not intended to protect from conditions on the inside of the enclosure. In other words, if we say an enclosure will protect from water, we're only talking about the outside of the enclosure, not on the inside of the enclosure. So if water does manage to get inside the enclosure somehow, we're not saying that the equipment inside of it will somehow be protected once the water has already gotten inside of it. So this is the table we talked about. We just mentioned Table 110.28, which is enclosure selection. So we're going to go through this table. It's a very simple table to use, which is a phrase you'll hear me reiterate almost every time we look at a table in the NEC. Because although they look very intimidating and confusing at first, once you break them down, they're very easy to use. So once again, starting with our rule of top left, we see we have a column of provides a degree of protection against the following environmental conditions. Looking at the top right, we have for outdoor use, and then the enclosure type number. So if we look on the left-hand side, we see for our first option under the column, or the heading of provides a degree of protection against, we see incidental contact with the enclosure equipment. Going right from there, we have a enclosure type number of 3, 3R, 3S, 3X, 3RX, and so on. And below all of those, in this circumstance, we have an X. That means that enclosure type number will provide protection against incidental contact with the enclosed equipment. So another example of this, if we go down to sleet and we go over to a type number, which we call a NEMA type 3, we see just a line. That means that a NEMA 3 enclosure type will not provide protection against sleet. However, if we go on over to a 3S, we have our X, meaning that a NEMA 3S enclosure will provide protection against sleet. Now moving a little bit down on this table, we have our headings kind of repeat down here. On the left-hand side, we see provides a degree of protection against the following environmental conditions. And if we go over to the right, now we see for indoor use and then the enclosure type number. So it's very important to note when you're looking at this table that the top half of this table is for outdoor use and the bottom half is for indoor use. We're going to use the bottom half the exact same way as we did for the top half. If we're looking for an enclosure that provides protection against falling dirt, for example, we're just going to go straight across until we hit an X. For falling dirt, we can see that every single enclosure type listed provides protection against that. However, if we go through towards the bottom of that column and look at corrosive agents, we see that only a NEMA 4X and a NEMA 6P enclosure provides protection against corrosive agents. And that is going to wrap up our third lecture of Module 1. In our next lecture and our final lecture for the module, we're going to be taking a look at tunnels and manholes, which will be covered in Part 5 of Article 110.